All right. All right. Welcome, everybody, to the continuing series of webinars from the Arizona Alzheimer's Disease Center Data Management and Statistics Core. Very excited to have our presenter today, Dr. Maud Wagner from the Rush University Medical Center. Before I introduce her, I'll just say that we will hold all questions until the end of Dr. Wagner's talk, and you can either submit your questions through the chat, or toward the end of the Q&A session, you can unmute yourself and ask Dr. Wagner in person your question. Also, this webinar is being recorded and will be posted on YouTube after the webinar is completed and will be available to view afterwards. All right, so our speaker for today is Dr. Maud Wagner, who is an assistant professor of neurological sciences and a biostatistician with Rush Alzheimer's Disease Center in Chicago. She received her PhD in biostatistics from Bordeaux University and completed her postdoc at the Rush Alzheimer's Disease Center. Her research focuses on identifying causal and modifiable lifestyle-related risk factors across the lifespan for dementia, cognitive decline, and cognitive reserve. She works on several international prospective cohorts and has a broad interest in longitudinal modeling, latent process mixed models, nonlinear mixed models, and R programming with applications, notably in brain aging and Alzheimer's disease and related dementias. So Maud, I'll go ahead and take it from here.
Thank you so much for the introduction. Good morning, everyone. So today, I will be mostly discussing a very important concept that is cognitive resilience to neuropathology. And I will talk about also about new longitudinal continuous measures that we developed at Rush to quantify this important concept at the individual level. So briefly, just to give you brief background. So I guess most of you already know what are the hallmarks of Alzheimer's, etc. But still, I prefer in case to give a brief background. So to date, we have some assumptions about the progression of brain lesions, very typical in Alzheimer's disease. So the two hallmarks are amyloid plaques and tangles that can start to progress in the brain decades before the first clinical manifestations. So it would appear that it's possible that there is first an accumulation in the brain of amyloid plaques, followed by tangles. Then neuron cells will start to die prematurely, leading to brain atrophy. And still here we are in a very asymptomatic stage. So everything is going fine, but still the disease is progressing in your brain. Then we have a clinical stage that is established and named mild cognitive impairment, MCI. So here it's fine. We can start to have some cognitive impairment, but because it does not interfere with independent living, it's still we are not sure to progress to dementia, and we can still to live correctly. But approximately 1/3 of people with MCI turned to the stage of dementia. And here it's clear that there are significant interference with independency in performing daily tasks. So we are talking about Alzheimer's, dementia. Sometimes it can be confusing. And so what is the difference? What can we use as a term? So briefly, again, sorry if you are very aware about this, but I prefer just to give you some background. So dementia is really in clinic something that we use as an umbrella term to reflect different symptoms that can affect cognitive functioning. So in particular, dementia is defined by memory loss and other cognitive ability that are affected. And this dementia syndrome can be caused by different diseases, including Alzheimer's dementia. So that's for sure. Alzheimer's corresponds to the most common form for dementia. If you consider 100 cases of dementia, approximately 60 to 70% of them will be demented because of Alzheimer's disease. But the thing is that it's much more complex at the same time, because we know now also that Alzheimer's pathology is often mixed with other pathology, vascular pathology or other neurodegenerative pathologies. So I just did on the left a list of the major pathologies that have been identified to be involved in the progression to dementia. And at Rush, at the Rush Alzheimer's Disease Center, where I'm working here, we are very specialized in brain autopsy, you know, looking at the brain of participants with or without cognitive impairment, proximate to death. And in a recent paper published by Patricia Boyle, it was very interesting to see that among approximately 1,000 ROSMAP participants, so cohorts that we have here, actually they found that more than 200 combinations of neuropathology was observed. So it's clear that even if trials are targeting specific hallmarks of Alzheimer's, so mostly plaques, amyloid plaques, actually these Alzheimer's hallmarks are never really working alone. They are in interaction with vascular or other neurodegenerative pathologies. And it's really something that we need to consider when we want to talk about treatment or prevention, or etc. It's real. So that's why today I really want to discuss something about cognitive resilience to Alzheimer's and other neuropathology, because it's something that we want to consider together. So the concept of cognitive resilience emerged from the observation that actually some people with no cognitive impairment proximate to death, actually when we looked at their brain doing a brain autopsy, we see a high quantity of pathology, Alzheimer's pathology, for example, and definitively they should have been diagnosed for dementia. But it's not the case. There is a big mismatch between their cognitive level and this quantity of brain lesions. And that's why we are calling them cognitive resilient. And we can see that approximately 1/3 of people older than 65 and plus years old can be cognitively resilient. And this percentage increase in the very old population. But it's incredible because actually it's a very important part of this older population. So of course, we would like to better understand how these brains can cope with the accumulating pathologic changes that are occurring in their brain. And here again, these individuals are very easy to identify because there is a big mismatch between cognition and pathology. So you have high cognition and high pathology, but it's more likely that this cognitive resilience can happen at different stages of the disease. But yeah, typically, if I go back to the theoretical cascade we talked about before for Alzheimer's, this accumulation of brain lesions, typically it means that these people, cognitively resilient, their brain are capable to face more neuropathologies before, to present symptoms. So typically to delay the standard stage where symptoms start to appear, clinically speaking. So it's really an interesting fact, because if we are able to identify, key protective factors for this cognitive resilience ability, maybe we can touch a big part of the population, and at the same time, we can also consider a more important variety of pathology in the brain of participants, patients, people in the population. So yeah, so far the very first studies defined this cognitive resilient concept when there were a very great departure between cognition and neuropathology. But as I mentioned before, it's more likely that cognitive resilience appears to occur across the entire clinical spectrum of cognitive health. So that's why previous researchers and our team also proposed to extend the definition of cognitive resilience by defining it through a continuum from worse to better than expected cognition, given a specific degree of pathology in the brain. So it's a relatively new concept. So there is no clear, consensus on how to define but also quantify this concept. But what is emerging more and more, and that is very practical, is the use actually of residual approaches that are able to give us enough statistical power in the quantification of the resilience continuum. So typically, when we talk about residual approaches, we are considering cross-sectional cognitive measures. It's very simple. You are running here a linear regression model. Your outcome corresponds to cognition, global cognition. And then you will put as predictors in your models demographics, okay, but also some pathological variables or biomarkers variables, depending on the data you may have. And what you are interested here are the residuals corresponding to the difference between what is observed and what is estimated, expected. Then when you are considering all this information, so all this pathology in the brain or through biomarkers. So here I just, for example, here, I'm representing these scatter plots. It's just a theoretical thing to give you an idea. But yeah, if you do a scatter plot of what is observed versus what is predicted in terms of global cognition, here the dot line corresponds to what would be strictly expected. And people in this area typically get higher level observed that would be expected. So it's like it's reflecting here resilience, high cognitive resilience. And in contrast, people on this part of the scatter plots present observed cognition that is the level is lower than expected. So then reflecting poor cognitive resilience. So that was the very first methods that was proposed to quantify this concept. But at the same time, for sure, it can be limited because first you are focusing on only one point for global cognition, while we are most likely interested in what is happening over time, so the cognitive trajectory. And also typically, the assumption is here, okay, we are considering residuals to quantify cognitive resilience, but residuals, normally, when you are doing a linear regression, it's typically the measurement error. So it can be questioned, we can discuss this. So, and at the same time, I totally agree. Sometimes, you just don't have longitudinal data. So you do what you can with what you have. So it's not a critique, but it's something that we need to take into account when we use this kind of cross-sectional method to quantify this TR measure at the individual level. So so again, you can use different predictors in your model. Here I will be mostly interested in neuropathology because I'm working mostly with the data we have here at Rush, and we have a lot of information for the neuropaths. So I will take the example of participants with brain autopsy at death, not biomarkers, but it can be totally transposed to this kind of data. So, okay, so the classical cross-sectional approach I just defined, I just wanted to present here a theoretical example and then do I just want to give you here a theoretical example for a participant followed over time, just to compare the different strategies we are using considering longitudinal data after. So, okay, so here, let's consider a participant with 5 repeated cognitive measures over time. So this participant, theoretical again, was followed for 12 years. He died here at time 0. A brain autopsy was performed. And if we want to quantify the CR concept using this cross-sectional residual approach, what we will do is to focus on the observation of global cognition proximate to death and run a linear regression model adjusted for neuropathology. So let's say that this kind of strategy to quantify CR is called CR last level. And the resilience will be defined as the discrepancy between what is observed versus what is estimated for global cognition. So typically here, what is observed, here, is lower than would be expected for a specific profile of neuropathology, so reflecting poor resilience. But then at Rush, where I'm working here, before my postdoc, because they have a lot of information for cognition over time, they suggested to quantify cognitive resilience, focusing on cognitive change over time. So typically now, we will consider all the information we have for global cognition over time, so all the 5 repeated measures for this participant in particular. And what we want to do is to use a mixed effects model adjusted for neuropathology again. And we will extract the residual random parameter related to the slope to define CR. So here I'm using the label CR slope. So the CR slope corresponds to the estimated random residual slope. And typically it corresponds to the individual deviation from the rate of cognitive decline expected at the marginal level. Okay, so if we go back to the theoretical example on the left, we see that, so in purple corresponds to the marginal estimated trajectory for global cognition. So what will be expected for the specific profile of neuropathology of this theoretical participant. But then when we look at the individual estimated trajectory in blue of this participant here, we see that there is a steepest cognitive decline compared to what would be expected at the population or marginal level. So because there is a steepest decline, the CR slope value will be negative. It corresponds to the random parameter of the slope, then reflecting a poor resilience to cognitive change. So it is another way to operationalize the concept of cognitive resilience to neuropathology. But here we are really focusing on slope. And the thing is that we know also that, of course, the level of cognition can be very important in the definition of the cognitive trajectory. So, and typically that's the case here. Okay, this person presents a steepest decline than expected, but still you can see that his cognitive level is not that bad. It's consistently higher compared to the marginal trajectory. So how is it possible to create a complementary measure accounting for these repeated cognitive levels over time? So to answer this question during my postdoc, we work on this and we propose a specific measure that I will just present after. So to look at these different strategies, longitudinal strategies to quantify the concept of cognitive resilience, really focusing on longitudinal cognitive measures, we use the data from the religious orders study and the data from the Rush Memory and Aging project. So these cohorts are ongoing, and the specificity is that people that agree to participate agree to annual cognitive testing and also, more importantly, to brain donation at the time of death. So for now, we have a very long follow-up. More than approximately 3,800 older adults have been enrolled so far. We have also a big amount of information for brain autopsy, approximately 2,000. And also what is exceptional is that we have a very, very good follow-up rates and also autopsy rates. So for this work, to really propose a new complementary cognitive resilience measure, I selected people from the ROS map with non-missing information for the 9 neuropathologies that are systematically examined in these cohorts. So typically it corresponds to the 9, the 9 neuropathologies I just listed here. Then I also wanted the participants to have a complete baseline clinical evaluation and to have at least 2 complete cognitive evaluation over time, because you remember one of the cognitive resilience measure is focusing on slope. So of course you at least you want to have 2 points over time to be able to estimate this individual slope over time. So briefly, the method is simple. We wanted to compare different strategies to quantify these CR measures. So typically, we considered the first one that is cross-sectional. So you focus on cognitive level proximate to death. The second measure was focusing on cognitive slopes. And the new one that I will describe was proposing to not only focusing on cognitive levels over time, but also be more flexible in terms of non-linearity of cognitive trajectories over time. So we compare the 3 different continuous measures in terms of distributions, person correlations, etc. And to validate the new measure, we also wanted to contrast associations between the 3 CR measures and establish risk factors for CR and considering essentially risk factors at study baseline. So we considered in particular years of education, late life cognitive activity, neuroticism, depressive symptoms, and also APOE4. So yeah, briefly to give you some equations and a more clear definition of how the models were specified. So for the first CR measure, so CR last level measure, focusing on proximate to death. So really, I considered a global cognition, again, proximate to death, and we entered as predictors age at death, sex, and the 9 pathological variables we systematically have at brain autopsy. And so the CRLS level corresponds to standardized residuals after estimation of the model. Then the CR slope, that is really focusing on residual slopes over time. So we use the linear mixed effect models, adjusted also for demographics and neuropathologies. We considered a linear function of time because we consider a linear function of time, and the CR slope was defined as the random parameter estimated. And because it seems, of course, to consider a linear function of time is a thing that we can do here, and it's very simple, and it facilitates the fact that we just have to extract one parameter, to define this deviation, individual deviation for the slope parameter. And here it's the new measure we suggested. So the thing is that we are still using a linear mixed effect models, but the difference with the first longitudinal measure is that we will consider a more flexible function of time. So here we are considering a function of time approximated by natural cubic spline. So it's convenient because you don't have to do an a priori assumption on the form of your trajectories, and it's very defined based on the data. So because we are essentially focusing on levels here, it was very convenient, and we wanted to be able to capture potential non-linearity acceleration of cognitive loss over time. So we use this kind of function of time. And yeah, so that is the main difference between the two models. But here, the information we will extract from the model to define the concept of cognitive resilience is, so here it's called CR mean level. So here we will really focus on what is happening between the individual trajectory in blue and the marginal trajectory here. We will look at the differences over time at observation time. So typically here, because these theoretical participants present consistently higher cognitive levels over time compared to the marginal estimated trajectory in purple, the CR mean level will be a positive value reflecting high cognitive resilience to when we are considering the level over time. Okay, so we have the three strategies. We have the cross-sectional that is used in many previous papers. Here is the recent CR slope focusing on residual slopes over time. And here is the new one focusing on levels over time. So, okay, so in terms of results, so the selected participants were predominantly women with a mean age of 80 years at enrollment and 90 years approximately at death. During a mean follow-up of 9 years, the median MMSE score decreased from 28 points at baseline to 25, approximate to death. And for the risk factors that we considered for the established risk factors of CR at baseline, we see that the mean years of education was 16, and individuals reported participating in 3 cognitively stimulating activities on average. We also have a mean level of neuroticism of 16, and approximately 25% of participants reported more than 2 depressive symptoms at baseline. And on the right, I'm representing the distributions of the 3 different CR measures. So CR last level for the cross-sectional strategy, CR slope focusing on slope, and CR mean level focusing on repeated levels over time. So we see that it could be expected, but so the correlation between CR last level and CR mean level actually is quite good because both are defined differently, but still they are both focusing on levels over time of global cognition. But then when we looked at the correlations between the CR slope values and the CR mean levels values, here there is more discrepancy with correlation of 0.46. That could be expected because here we are really considering a different information to define the CR measures. Okay, so here I just wanted to give you, to help illustrate how specific context may lead to differences in the score of resilience across strategies. Here I represented a participant, so a real one, in the ROSMAP cohort, who presented 3 Z-scores of CR that differed substantially. So I'm considering a standardized Z-scores for the 3 different measures to make them comparable, of course. And it's very interesting because, so graphically still, the estimated person-specific and marginal trajectory are represented here in blue and purple. And we see that these participants had slow cognitive decline in the 10 years before death, yet consistently lower estimated levels of cognition compared with the marginal trajectory. So in this case, the Z-score for CR slope is equal to 1.53, that's high, while the value of CR mean level is low, reflected by a score of minus 0.97. And on another hand, due to the convergence of trajectory approaching death, then we see that the CR last level value is close to 0. Yeah, so we clearly see here that depending of what kind of quantification you are considering, how you are defining your concept, you can have different values that can reflect different dimension of the CR concept. So finally, yeah, when we looked at the associations between risk factors of CR and the Z-scores of resilience measures, we see that the effect estimates generally show the same direction of association, so indicating that each provides consistently informative results. So as expected, also relations were also consistently stronger for the new CR mean levels, so that is a good news. So interesting, however, some factors were more clearly associated with levels of cognition, while some appeared to be related to both levels of cognition and the rates of cognitive decline over time. So for example, here for education, we see that the years of education was strongly related to both CR last level and CR mean level, but there was no relation with the CR slope. Sorry. Okay. So in contrast, for neuroticism, that is a trait disposition to negative affects, we found an association with CR last level, CR slope, and CR mean level. And this may indicate that neuroticism is related to multiple dimensions of CR again. And typically, that's the if we agree with this assumption that we are here looking at different measures of CR that are capturing different dimensions of the concept, it's what we want. We want to identify protective effects or risk factors that can, apply to at the same time at different dimensions of the CR to optimize the benefits of lifestyle intervention, for example. So yeah, so when we are focusing on the longitudinal CR measures, we think that they are very complementary. And why? Essentially because when we look at the CR mean level measure, focusing again on the cognitive levels over time, so the differences between what is estimated at the individual versus what is estimated at the marginal level, so what would be expected. So we know that this measure is highly related to baseline cognitive level. So where you start, of course, will be important and condition a little bit where you will end. So because also cognitive decline, we know that it's a progressive signal that is declining slowly over time. Potentially, this CR mean level is more reflecting the accumulation of cognitive resources through older ages. And in contrast, for CR slope, because we are mostly focusing on what is happening right now in older ages, what are you losing right now? It may be more a reflex of an immediate resilience to neuropathology. So that's why we think that these two measures together can be very complementary in the identification of risk factors in the future. So yes, so briefly, for the new CR mean level measure that we proposed, it's true that main strengths that we can mention is that it allows for flexible fits, accommodating, potential nonlinear cognitive trajectories with acceleration of cognitive decline, especially before death here, where sometimes we know that there are some terminal decline in the 3 years proximate to death, and there is a clear acceleration in this cognitive loss. Also, it's very important, and I want to be clear on that, but here I use neuropathology data in my models, but you can definitively translate this definition, this CR measure, just by using biomarkers or other kind of data. So, but of course, here you need repeated data for cognition. So, but still, it's very simple to just replace your predictors and that's it. And yeah, and so we also think that the associations we found validated this new measure because we found that it was highly associated with several established risk factors of CR at baseline, and the associations also were stronger for CR mean level than CR last level that was a cross-sectional CR measure. So yeah, using longitudinal data in the definition of your CR concept can be good and improve your definition at the individual level. But of course, there are also some limitations. First, because we are looking at trajectories of the time, it can happen sometimes that the trajectories, cross. And then what do we do in such situation? So that's true that here currently the CR mean level measure that we proposed is definitely unable to capture the possible change in direction of the differences with the marginal level. But at the same time, when we observed in our cohorts, at least that it was the case for fewer than 1% of participants. So it was very rare that we have, these cross trajectories, etc. So yeah, but of course, if you want to apply it in your data, you have to check if it happens and how it could be considered. And finally, yeah, because we are here considering estimations from a model specified based on different variables, etc. If you want to do comparison from studies to studies, it can be very limited. Yeah, but to conclude with both CR mean level and CR slope, now we think that future research may benefit from being able to consider risk factors that contribute both to maintain higher levels of cognition than expected over time, as well as to get flatter slopes of cognitive decline. So to maintain and prevent is really something that if you are interested in, it's together these two CR measures can help us to identify this kind of risk factors. What time is it? Okay. So here I'm sharing the paper. So the results I just presented before was published in Alzheimer's and Dementia. You have a lot of details on the different quantification. I'm also sharing in supplementary some R codes if you need to replicate things or I don't know. So yeah, and if you have questions, please do not hesitate to reach me. I will be pleased to answer any questions. Yeah, I have time quickly to just talk about also an application we did recently where we wanted to look at association between a recent dietary pattern, so the MIND diet for Mediterranean DASH intervention for neurodegenerative delay, and with the cognitive resilience measures using all, defined using all the longitudinal cognitive measures over time. So yeah, I would like let some time to the question, but typically we focused so to answer this research question, do we have an association between healthier dietary patterns and these cognitive resilience measures? We have focused on the Rush Memory and Aging project because this is the only cohort at Rush where we have data for diet. My analysis were considering 578 descendants with at least one completed FFQ over time, with no clinical diagnosis of dementia at the first dietary assessment, so here corresponding to the analytical baseline. We still wanted to have participants with at least 2 complete cognitive evaluations starting at analytical baseline, and non-missing data for the 9 neuropathological variables we are interested in. So briefly to define the MIND diet score, how it is quantified. So it's a recent diet that was developed by Martha Claire Maurice in 2015, and it's defined through 15 components. You have some components to favor, some of them are to limits, and for each of these components, you will receive a score of 0, 0.5, or 1, depending on specific frequency and servings. So if you have a very poor adherence, if you don't adhere to the diet, you have a score of 0. If your adherence is perfect, then you get a score of 15 points. So we just focus here on the two longitudinal CR measures, so CR slope again and CR mean level. And we looked at the associations between the MIND diets and these two different measures. And our research, we have our hypothesis was that, of course, greater MIND diet scores were associated with higher CR scores. And when we run the analysis, we also try to consider major confounders, notably smoking status, depressive symptoms, medical conditions, physical activity, and cognitive activity at analytical baseline. And yeah, so here just again the definition of how we specify the model to define the different CR measures. And here are the main results, where we found that definitively higher, so people with a moderate or a great adherence to the MIND diet score presented definitively and significantly, greater levels of CR mean levels and also greater CR slope levels. So meaning that it was, so participants with higher adherence to the MIND diet score benefits to this, to greater cognitive resilience on these two different dimensions. So it's very the first study where it was possible for us, to look at all the different things together, because we have cognition, neuropath, and diet in the same cohort. So we would like to see other studies if they are finding the same results. But yeah, it's very promising so far. Yeah. So again, here the results have been published. You can find more details in the publication. And yeah, so I will now give some general concluding remarks. So relative to the different longitudinal CR measures, focusing on both cognitive levels over time, cognitive decline can really provide complementary ways to evaluate and quantify CR. Again, future research may benefit from being able to consider risk factors that contribute both to maintain higher levels of cognition than expected over time. If you find association with CR mean levels and risk factors, then this is the case. And we want also to find risk factors that contribute to flatter slopes of cognitive decline over time. So looking at risk factors associated with CR slope. And yeah, and thanks to this, we could broadly promote CR and delay the onset of clinical dementia. Because in this context where we do not have a strong therapeutic answer for families, for patients, etc. right now, to work on the thing that brains can be able to face more brain lesions than expected, and then to delay the onset of dementia is essential, actually. So even if the disease is here, we still can find ways to delay the onset and the manifestation of the first clinical symptoms. And yeah, and just to give you also to conclude about the application we did with the MIND diet, it's promising to see that healthy dietary habits may be a candidate by simultaneously promoting and preserving cognitive resilience in older adults. So yeah, here I'm just sharing, the ADC Research Sharing Hub, where you can, if you want, ask data for free if you have research projects for CR, of course, but other things. So it's really a very interesting platform, and you can visualize all the data we have here, etc., etc. And yeah, so I would like to thank my collaborators, the study participants, of course, also my founders of my postdocs, so the French Foundation for the Alzheimer's Research. And thank you so much. And if you have questions, please, ask.
All right, thank you so much, Maud. That was a great talk. So anybody who has questions, you're free to either unmute yourself and ask in person, or if you want to put it through the chat, I will moderate it and ask it on your behalf. So any questions or comments, feel free to go ahead and talk if you prefer. So Maud, I'll just start off with a very kind of a basic question. So, there's different controversies around how one actually measures, cognitive resilience and cognitive reserve. And it seems like in your models, you have, different components of it. So you had a personality component, a, mind activity component, and the education component. Um, so what is your feeling, and just generally how you think that the construct of cognitive reserve and cognitive resilience can be best measured?
Yeah, so again, I want to be clear, I'm not saying here what I'm suggesting here is the best, etc., etc. It's super interesting because it's a recent concept. A lot of different groups are working together to really operationalize at best this important concept. And it's very important to do it because we see that publications on reserve, cognitive resilience, are increasing a lot. And sometimes the terminology, it can be very confusing because people can use the term reserve, some others resilience, etc. So I think in few years, it will be um, more and more clear, how we want to define specific concepts and how we, if I want to focus on cognitive resilience, you can use this term if you are entering specific things in your models, etc., etc. So, but there is a big consensus that is more, you can see cognitive reserve as a whole thing, and then you are looking at resistance versus resilience, etc., etc. So here I wanted to use the term cognitive resilience because we are in the presence of brains that present neuropathology. So when the disease is here, when there are progression of brain lesions, then you are not anymore resistant to the pathology because they are really there. Resistance is really to avoid the accumulation of brain pathology. So there are some terminologies like that that help us to clarify, what we are talking about. But still, people can have some conflicts saying, no, I want to use the term reserve for this. No, I want. So there are still discussions, there are workshops that are organized, etc. There is also a very important website created by Dr. Stern, Jakob Stern, where they are, it's the Reserve and Resilience website, where you have a lot of recommendations. So if there are some guidelines, but yeah, things are progressing in a very good way. And I don't, sorry, but it's really, it's really new. And we try to be, you need to be precise when you talk about resilience, etc. So that's why also I'm talking about cognitive resilience to neuropathology, because sometimes you have cognitive resilience to genetic susceptibility, for example. It's very depending of what you are facing, are you facing neuropath or are you facing genetic susceptibility again? So you have to be very precise to help also people to be confused and to do comparison from one study to another, etc. So it's in progress, and there are a lot of work going on to clarify this different terminology and how to operationalize them.
Thank you. So we had one question coming through the chat from Dr. Alex Wygand. So first she says, really excellent talk. What do you believe the mechanism is for the mind diet promoting cognitive resilience? Is the idea that it leads to reduced neuroinflammation, which may consequently reduce the harmful effects of neuropathology?
Yeah, so I can answer because of course, there are some hypotheses. So first, we know, for example, that the mind diet, has antioxidant properties that can help to preserve neuron cells and also decrease inflammation, as you said. And yeah, so because you preserve this your neuron cells, you have more cognitive reserve. So then you potentially your brain is capable to face a more amount of lesions before to to present the first symptoms. So it's thanks to these recent findings, it's clear that we have to continue to better understand what is happening. And people at Rush are really looking at this kind of mechanisms. For example, Dr. Pooja Agarwal, she's writing a grant right now, looking very interesting in this link between cognitive resilience and diet. So we will get answers soon, but there are this antioxidant, the fact that also diet can help to facilitate, the vascular health of the brain, etc. So yeah, I don't have any clear answer, sorry, but of course these kind of potential pathways are in the list.
All right. Any other questions or comments for Dr. Wagner? All right. Well, if there are not, Maud, thank you again for your wonderful presentation today. I appreciate you taking the time for it. And Dr. Wagner's talk will be, the recording of it will be posted shortly later today on YouTube, and I will send the link out to everybody who registered for this webinar. And I can say that our next webinar will be in April, and more details will come about that, about who our speaker will be in the topic. So be on the lookout for that. If not, have a wonderful rest of the day, and thanks again to Dr. Wagner for her time and talk today. Appreciate it very much.
Thank you, everyone.